Okay, now the recording has started. Okay, again, this is lecture 15, and today we'll be discussing decision tree learning. Uh, so we mentioned that decision tree is a specific type of data structure, and it consists of nodes and edges. Uh, of course, it starts from one node, which is called a root node, and then from there you have edges that go down to the last node, which you can say is the leaf node. So internal nodes, non-leaf nodes are decision nodes, and leaf nodes, of course, are class nodes. And this structure can be used for classification as well as for regression. And the whole idea in data mining is to learn this structure from data, to build this structure or this model from data. So, so let's directly dive into this. Just a second. So basically, so decision tree, the internal nodes, for example, the root node is basically a decision node. So let's say this is an attribute x1, some attribute, let's say gender. So the decision node is the two edges of this node would be the two decisions that are possible or two possible values for this attribute. For example, this left edge is male and the right edge is female. And as you go down the left edge, you might have another decision node, which might be, let's say, x2. X2 could be something else, let's say, education of the individual. And let's say there are three possible education, you will then have three edges. Until you reach a leaf node, so leaf node can be shown as, you can say, squares or rectangles. Internal nodes can be shown as circles. Of course, this convention is not standard. Some books may use the reverse. So the leaf node would actually have the label. So let's say we are talking about buying a computer or not buying a computer. So this, let's say, is computer, yes. So, and maybe another leaf node might, some other leaf node might give to computer, no. So this structure is the decision tree, and the idea is we want to learn this structure from data. And data is, of course, what? We have data regarding people with their gender, their education status, with their age, and their previous behaviors regarding whether they will buy a laptop or computer or not. So it's labeled data, as they say in machine learning. So the question is, how do you learn this data? How do you learn this model? So what do you decide as the decision node? What do you decide as the attribute at a particular decision node? So basically, and then of course you have to build the entire tree. So generally, the decision tree learning algorithms have these properties or characteristics, you can say. So generally, we have a greedy approach, meaning that we will start with the best and the next best and the next best for the decision node. So it's a greedy approach. And the approach, another characteristic, again, from an algorithmic perspective, is we have a divide. We use a divide and conquer strategy. meaning that we will, given the entire data, we'll find the best attribute first, of course, which is greedy. And then, we divide the data according to that, and then move on to the divided data and find the next best attribute and so on. So, and of course, this process is repeated, so it is often called recursive. Okay? So the approach is recursive. And so these are some algorithmic properties of the learning algorithm. Of course, from a machine learning perspective, as I said, it is supervised learning. And another characteristic from a machine learning perspective is this is sometimes also called information theoretic approach. So it is not a probabilistic approach, and it is not a statistical approach in the purest sense. It's an information theoretic approach for learning. And as opposed to, for example, naive-Bayes, which would be a probabilistic approach. Okay? So this is a couple of characteristics from the machine learning perspective. And finally, characteristic with respect to why decision trees are popular. So why decision trees are popular? One reason is that they are easy to interpret, at least the simplest form of. So not a black box. So once you have built the decision tree, that decision tree will provide you reasonably good insights about why a particular decision has been made. On the flip side, if you think of a neural network for classification or regression, a neural network typically provides little information about why that decision was made. So it's more of a black box, not a white box. So it's easy to interpret. So that's one thing. And generally, it's reasonably good performance in terms of accuracy if you're talking about classification for many applications. And it's often used as a common baseline. So one of the first techniques that you might apply for any application, classification or regression task might be a decision tree. And it's also sometimes said that it's robust to things like what did you say? अच्छा एक second.
सर वो मेन्यू बीच बीच में ओपन हो जाता है
जी
सर वो गेम बार का मेन्यू ओपन हो जाता है तो वो स्क्रीन विजिबल नहीं होती
गेम बार आया हुआ है ओहो अच्छा
यस सर अब चला गया सर वो आ जाता है बीच में यस सर
गेम बार वैसे क्यों खुल गया था लेट मी सी अच्छा अब नजर आ रही स्क्रीन
यस सर अब विजिबल
ठीक है so it's accurate for many applications robust to so common you can say scaling and translation issues you can say so for example if you have a data set in which you have income which typically would range from let's say 10K to 100K or 1000K, and you have another attribute which is age, we typically range from 0 to 100. So usually you do not need normalization for applying decision tree algorithms. Remember we talked about normalization in data preprocessing. So you do not need normalization while you are running or building a decision tree because all attributes are processed independently and though they typically do not impact one another. Okay? So these are some of the, you can say, positives of the algorithm. So we'll discuss some negatives later on. So I've highlighted some characteristics from a machine learning perspective, from an algorithmic perspective, as well as some pros of decision tree algorithm. So decision tree algorithm also is one of the first, you can say, one of the first algorithm that became really popular among the, you can say, masses. And it also is a technique that made machine learning popular in the 1980s. Of course, the basic idea of decision tree learning was available since the 1970s or earlier even, but it became popular in the 1980s and was picked up by many application areas from the sciences as well as the social sciences and the humanities. So, and it's one of the reasons for the great popularity of machine learning since then in the 1980s. All right. So let me now discuss the issues here. So we said it's going to be a greedy approach, a divide and conquer approach. So what we, at the start, we'll have to find the decision tree at the root node. So let me just take a hypothetical example for classification example. Let's say we have gender uh, in, of course, male and female. And let's say we have age, let's say, uh, uh, so uh, so I would say teen, and let's say 20s and above 30. So teen, 3 labels. And let's say we have a third attribute, let's say education. So let's say pre-graduation, so graduation, and then post-grad. Okay? And then, of course, we have the fourth attribute, which is a class label. So label, or I would just say class. What happened? All right. So we were talking about class in, so so the class, let's say, of course, is buys a computer, yes or no. Okay. So let's say this is a simple uh, hypothetical problem that we want to tackle. And let me say I give these attributes now in order symbols. So x1 is gender, x2 is age, x3 is, of course, education, and then, of course, class label, let me just say C. Okay. So if you want to use a greedy approach and we want to select which attribute to choose as the root node, so we have 3 options. We have x1, x2, x3. And of course, notice that each of these attributes, I have chosen them to be nominal. Of course, decision tree can be applied to ordinal as well as real valued attributes. We'll discuss those variations later on. So we have 3 options. So what do we need? We need an attribute selection criterion or splitting criterion. So we understand what it means by splitting. So we need a criterion in general to decide which attribute to use. So we need to have a splitting criterion. So there are a number of splitting criterions available. We will start with the basic one, which is information gain, which is, of course, similar to entropy. Okay? And we had already discussed this very briefly when we talked about data preprocessing and discretization. So the same thing is applied here, but here I'm going to go into slightly bit more detail. The keyboard is not working properly. Something wrong. All right. So seems to be some issues. All right. So we would like to use this measure of entropy to find out which is the best attribute to select at any particular given point in time. So at the start, we have the complete data set, the training data set D, which is of course your X's for all examples and the corresponding C's, class labels. You can I, of course,
screens open है वो नीचे
1 to n. So you have all of this available to us. Of course, X here is a vector, X1, X2, X3. ठीक है ना? So all the
सर ऊपर स्क्रीन्स ओपन है तो वो नीचे नोटपैड नजर नहीं आ रहा, इट्स नॉट विजिबल।
चलो कोई कुछ इशू चल रहा है, आई डोंट नो।
कैप्चरिंग वाली जो है ना, कैप्चरिंग अब ठीक हो गया, ठीक है ठीक है। हां यस
सर वो
आती भी
की
नहीं
प्रेस
मुझे।
हो जाती होगी, आई थिंक ऑल्ट या विंडोज वाली, उससे ओपन हो जाती है ये स्क्रीन।
Something is causing an issue. Let me now stop this thing. Let me just a sec. Now stop the share. नजर आ रही है?
यस सर।
क्या मतलब स्क्रीन नजर आ रही है कि वो ऊपर वो भी नजर आ रहा है?
सर नहीं, नोटपैड है अभी विजिबल है।
ये ठीक है ना?
यस सर।
अच्छा, all right. All right, so let me take an example, quick example, and show you how this is computed. So let's say we have the data set D, and from the data set, we have some values for X1, and we have the class label as well. So let me just write some, so we are writing X1 and C, just X1, which is gender. So let's say we have male and class is, let's say 1, buys the computer. So we have another male, class is, let's say 1, and we have female, class is 1, and we have female, class is 0, and we have female, class is 0. Okay? So we are considering each attribute separately. So there are 3 females and 2 males, right? So what we do is we will try to find how, so we'll first find the entropy of the data. So entropy of the data, in this case, just 5 examples. So they are so the three males and 2 females, sorry, 3 buys of the computer and 2 not buying of the computer. So what would be the entropy of that? So the percentage of buy or 1 is 3/5. The percentage of not buying is 2/5. So essentially entropy is defined as basically minus the percentage or proportion of the class, one class. We have to sum over all classes, of course, into log, usually log 2 of the same pi. And of course, we sum over all I. And I, of course, is equal to 1 to k, where k is the number of classes. In this case, they are just 2. So the entropy of the original data set, in which we are just considering the class labels, is essentially then minus three over 5 into log 3/5, then minus the second one, 2/5 into log 2/5. I don't know if this will be computed or not. So it is computed, so 0.67, and I don't know if it uses a natural log or log 10, but it doesn't make a big difference. But जो भी आप log use करें, वो consistently use करें. But in the theoretical sense, log 2 वो कहते हैं because they're related to bits. ठीक है, so this is the entropy of the data set, which has 3 buys of the computer and 2 not buys. And entropy, lower entropy is considered better in the sense that it is represent homogeneous data set. Higher entropies means in impurity or inhomogeneous data set. So here, since you know that there are 3, almost half of them are one class, other half is other class, so it's kind of more towards inhomogeneity or impurity. So now the idea here is that, so this is the entropy of the data set. We want to select that attribute that will reduce the entropy the maximum. So that reduction is actually quantified by information gain. So in this case, we are going to consider it with respect to this attribute x1, which is gender. So let's see. So if I select x1 as the attribute, it will have 2 branches. One branch would be male, the other branch would be female, because there are 2 possible values of x1. So if I follow the branch of M, which is male, I get a class of 1. So meaning that if you follow the branch of M, you're filtering the data on M. So if I take the M branch, in this branch, I'll have just 2 examples or 3 examples. 2 examples. So M, one male and the other male. So both of them are M, and both of them are what? M is C, sorry, 1. And this is also 1. So both of them belongs to the first class. So this is a filtered data set for the M value of this attribute. So this filtered data set is now homogeneous. Both values are class 1. So if I wanted to compute its entropy, this would simply be, basically there are 2 examples belonging to the same class. So minus 2/2 into log 2/2. So you get an entropy of 0, which means that it is homogeneous. Okay? And let's say the other F branch has 2. So we have F1, and then you have F1, 0, and the F0. So there are 2 that are class 0 and 1 that is class 1. So if I compute the entropy here, what do I get? Minus. So 1/3 into log 1/3 minus 2/3 into log 2/3. So 0.635. So now we have two branches or two splits of the data. The original data was 5 examples. The left split, the male split had 2 examples. The right female split has 3 examples. And male split की भी entropy आ गई, which is actually 0. Female जो split की है वो entropy 0.636 है. So we need to compute the entropy after the split, because there are now two splits in a weighted fashion, because split जो left वाली है उसमें 2 examples थे और right वाले में 3 examples थे. So weighted entropy. So if I entropy after split would be, so if you look at the left split, the male split, उसमें 2 examples थी. Total examples कितनी थी? 5 थी. ठीक है. So 2/5 weight हो गया multiplied with 0, because entropy इसकी 0 थी. Plus right split में मेरे पास 3 थी, 3/5 into 0.636. So 0.38. ठीक है. ये entropy now is after the split. So what was the entropy before the split? So 0.673. So that was the entropy before split. Entropy after the split is 0.381. So the information gain for the attribute x1 is basically the entropy before split minus entropy after split, which is equal to entropy before split was 0.67 minus 0.381, 0.381. So this is the information gain for attribute x1, 0.281. Okay. So of course there is a positive information gain. So there is some benefit in splitting the data using x1. After splitting, you get more homogeneous data with respect to the class label. The left label, which is the right split, which is all males, is all 1, meaning, while the right has some impurity of there is 1, 1, and the other 2 are zeros. Okay. So this is IG for x1. You will have to compute IG for x2 also, IG for x3 also. The one that has the highest IG information gain would be chosen as the root node. Okay. Is this point clear? So this is the greediness and the divide and conquer type of thing that we're talking about. We are using a splitting criterion, in this case, information gain or entropy. We computed the entropy before the split, and then after splitting the data using the attribute, we computed the entropy for each split separately, and then took the weighted average. That was the entropy after the split, then did the minus, and we got the gain. And we do it for all. So you will do information gain for x1, information gain for x2, information gain for x3, and select the attribute with highest. Okay. So that would be the root node. So once you have selected the attribute root node, now you follow each of those 2 paths and repeat the steps at the lower levels. So if I go back to my so this was now x1. So now you have taken the left m तो यहाँ आपने फिर डिसाइड करना है इधर क्या होगा. इधर आपके पास कौन से एग्जाम्पल्स आ रहे हैं? ऑल द मेल्स एग्जाम्पल्स. And in this case, of course, this was all pure. This was class 1, this was class 1. So actually, you cannot do any further split. This node is homogeneous. ये class label हो गया आपका 1. ठीक है? While on the right hand side, we had female. So, second time. So if you talk about the right split, तो ये फीमेल था, इसमें प्योरिटी अभी नहीं आई. इसमें अभी क्या था? आपके पास एक क्लास 1 था, बाकी 2 0 थे. इट्स नॉट प्योर. सो यू कैन फर्दर डिसाइड के इधर क्या आपने करना है, चूज करना है टू फर्दर मेक इट प्योर. So here the options that you have are x2 and x3. So this is your data set, which is 1 0 0, and now you try x2 and x3 and again repeat the process of finding the best at this point. ठीक है? So let's say आपने कोई x2 यहाँ select कर लिया, तो जो भी x2 की values होंगी नीचे आएंगी. If this become pures, you stop there. So then you are done with the tree. Left जो part था वो male first split के बाद ही pure हो गया, right पे 2 splits के बाद pure हो गया. So a greedy way of selecting the attributes in sequence to lead to a decision which is hopefully pure, in the sense that there is no impurity with respect to the label at that point. Okay, any questions? So this process is repeated at each node, as I said, with the data that is filtered to that node. So recursion and divide and conquer, because you are filtering the data with respect to the node, the value at the previous level. And if, so basically what is the stopping criteria, of course, when do you stop? So of course you stop when node becomes pure, meaning that there is no inhomogeneity or homogeneous, or in other words, all data points have same label. ठीक है? So that is when you stop. But oftentimes for larger data sets and more complex problems, you would not reach a state where all objects or data points reaching a particular node are pure or homogeneous. So then in that case, we basically use some other measure, for example, entropy at that level of the data set. If that entropy is less than some threshold, let's say epsilon, then you stop, where epsilon could be a small number. So of course, ideally entropy should be 0. ठीक है ना? But we will allow some impurity and maybe stop growing the tree. That could be a stopping criteria. If epsilon could be, let's say 0.0, 0.01, for example. So you stop if epsilon at a given node, entropy at a given node is less than this epsilon. Okay. And then another scenario would be when we have used all attributes. So that is a natural stopping criteria. So let's say मैंने x1 root node के लिए use किया and I'm taking the right path. उसके बाद x2 मैंने use कर लिया. उसके बाद फिर मैंने x3 use कर लिया. After that, I don't have any additional attribute in my data set. So after that, obviously, I'll need to make the class or leaf node with the class label. Okay? So these are 3 possibilities for stopping the growth of the tree. Okay, so so the splitting criteria that I talked about is the entropy or information gain, and another criteria that is used sometimes, although entropy is the more common, is called the Gini impurity or Gini index. So the Gini is just like entropy is a quantification of the impurity, okay? And I mentioned this as G. So Gini is basically given as basically 1 minus sum over all classes of the proportions of those classes square. So Pi square. Okay. So for our case, let's say we talk about the original data set. Original data set had 2 1s and 3 zeros, or actually 3 1s and 2 zeros. So 2 classes हैं, तो उसकी entropy क्या बनेगी? Gini index क्या बनेगा? 1 minus. So the first one is 3 over 5 squared minus 2 over 5 square. I don't know ये निकालेगा कि निकालेगा. So 0.48. ठीक है ना? So this is the entropy of the original data set. And similarly, after the split, sorry, Gini of the original data set, similarly, you compute the Gini after the split. ठीक है? And then you can compute the gain. ठीक है? So information gain would then be Gini before split minus Gini after split. Of course, Gini after split would be weighted by the number of examples in each split. ठीक है? And then you make the decision. So if you have more than 2 classes, of course, जी.
इंफॉर्मेशन गेन में हम एंट्रोपी बिफोर स्प्लिट माइनस एंट्रोपी आफ्टर स्प्लिट नहीं था, तो ये जीनी ठीक है.
एंट्रोपी
मतलब इंफॉर्मेशन गेन का जो आपने पहले फॉर्मूला लिखवाया था वो एंट्रोपी बिफोर स्प्लिट माइनस एंट्रोपी आफ्टर स्प्लिट था. तो ये डिफरेंट है या ये भी एंट्रोपी ही है जीनी?
हाँ ठीक है, उल्टा लिख दिया मैंने. नहीं, बिफोर ही लिखा है ना. जिनी बिफोर स्प्लिट माइनस जिनी आफ्टर स्प्लिट, और उसमें भी एंट्रोपी बिफोर स्प्लिट माइनस एंट्रोपी आफ्टर स्प्लिट.
तो ये दोनों फॉर्मूलास है इंफॉर्मेशन गेन के?
जी,
ये दोनों फॉर्मूलास है इंफॉर्मेशन गेन के?
हाँ, दोनों फॉर्मूला सेम है. ओनली द मेजर इन द प्रीवियस केस वाज एंट्रोपी, इन दिस केस इज जिनी.
तो बेसिकली ये जीनी इंडेक्स है क्या?
समझ नहीं, फिर से बोले.
सर जीनी इंडेक्स है क्या? मतलब एंट्रोपी की तो समझ आ गई थी.
It's a replacement for the entropy. So it also quantifies impurity, just like entropy quantifies impurity or inhomogeneity. So Gini also quantifies impurity or inhomogeneity.
तो एंट्रोपी के बजाय ये भी निकाल ले इस तरह तो इट्स फाइन.
Yeah, it's an option that is available to you. You can use either entropy, which I said is more common or more popular. Gini is less popular, but still a measure that can be used instead of entropy. Okay, but remaining process remains the same. Gain हम उसी तरह निकालेंगे जिसमें पहले निकालते थे. Okay, finally, one more measure before I move on to regression. So gain ratio. Of course, there are many other measures as well. So gain ratio is basically information gain, जो भी जिस तरीके से भी निकाला, usually entropy से निकाला, divided by intrinsic value of the attribute. So we are actually talking about a specific attribute, right? So of some attribute x1, let's say, x1. So this is also x1. So we are talking about a specific attribute. सो उस स्पेसिफिक एट्रीब्यूट का आपने इंफॉर्मेशन गेन निकाला और उस एट्रीब्यूट का फिर आपने IV भी निकालना है. सो वी विल explain the reasoning behind this shortly. So basically intrinsic value basically quantifies the impurity of values in the attribute. Okay. So for example, let's say we talked about the attribute gender. So gender में दो possible values हैं, male and female. And in our given data set, we had three, I think 2 males and 3 females. So the intrinsic value of this attribute would then be the entropy of this inhomogeneity of this set. So entropy इसका क्या होगा? Minus 2/5 into log 2/5 minus 3/5 into log 3/5, which is of course वही 0.67 आएगा. ठीक है? So this is the intrinsic value of this attribute. So now let's say if you have another attribute, hypothetical attribute, let's say x2 कोई attribute ले लेता हूँ जिसमें 5 possible values हैं, और in my data set I have one value, so one value of each or equal number of values for each of those classes. So in our data set, let's say मैं कहता हूँ A, B, C, D and E, 5 possible labels हैं, values हैं उस data set की, और मेरे पास एक example A की है, एक B की है, एक C की है, एक D की है, एक E की है. So इसकी जब आप intrinsic value निकालेंगे, it will be much higher. ठीक है? So why? Of course we are computing the entropy, right? So it is 1/5 into log 1/5. Of course ये 5 into, which will give you a 1. ठीक है? It's going to be high. So, and if you look at the gain ratio formula, gain ratio में ऊपर IG आ रहा है, नीचे IV आ रहा है. So in other words, we are penalizing attributes which have a high IV, because IV से divide हो रहा है ना. ठीक है? So now the question is, why do we want to do that? Because in our data set, there might be some attributes that have a large number of distinct values. There might be other attributes that have few number of distinct values. And in the limit case, you might have something like the example that I mentioned. There is as many distinct values as number of examples, training examples. Think of like a unique ID that is used as an attribute. So if you use a unique ID as an attribute, so let's say यही example लेता हूँ, आप उसको select कर लें, x2 को select कर लें as a root node, it will have 5 branches. It will have 5 branches. Each of them would have just one example in it. And of course, it will be pure because एक example, it will belong to just one class. Okay? So this is an undesirable solution. We want a solution that is based on attributes which would lead to some decision. This is like a trivial decision which we already know. A unique ID किसी data set का would always classify the data set perfectly, but a unique ID is not an attribute of an object or is not a descriptor of an object. So कोई नया object आता है उसका unique ID से आप characterize classify करना चाहें, that is not the point. We want to classify based on some feature of that object like gender or age or something else. So we would like to penalize such attributes which naturally would lead to good classification and give preference to those that would give classification that are more useful in practice. So ye major kind of caters to that. You divide it with IE and then of course decide based on the highest gain ratio. Okay? So instead of now deciding based on IG, now you decide based on GR. So you have GR for X1, we have GR for X2, you have GR for X3. Select the attribute with highest GR. Okay? And of course, GR is IG over IV. So if an attribute ka IG high tha, but it's also intrinsic value bhi high thi, तो उसका GR कम हो जाएगा. ठीक है, so these are the three measures that we will talk about in classification. And so we have already talked about the stopping criteria. Either you have utilized all the attributes or your leaf node becomes pure, or the more practical scenario would be you put a threshold on the entropy. If the entropy becomes less than some small value, then you stop growing the tree. Okay, so this will build the tree in a greedy fashion. Once the tree has been built, you can use it for future classifications. So before I move on to some other topics, let me quickly discuss regression. So regression, the regression problem is that leaf node has continuous value. So you can think of यही जो मैंने अभी problem बताई थी, gender, age, or education. And let's say my class attribute is, let's say, score on, let's say, SAT set. So this is a continuous value, obviously. Okay? So now we want to not predict a label from a possible set of labels, but now we want to predict a continuous value. And of course, you will have data set for this. So आपके पास कोई होगा data set M male है और उसकी age let's say teen है और उसका education I don't know क्या था हमने decide किया pre-grad और उसका score I don't know SAT के scores कहाँ तक जाते हैं 250 let's say. And similarly you have other examples like that. So इस case में क्या होगा? So how do you determine the purity of a set? So let's say आपका original data set है, which is all examples. उसमें मैं सिर्फ वो लिख रहा हूँ, SAT के scores लिख रहा हूँ, 250, 260, 280, 200, and 300. ठीक है? So one way to quantify the purity of a set, which is consisted of continuous values, is to find the deviation from the mean. ठीक है? ठीक है? So इसका representative value क्या होगी? It will be the mean of this possible set of scores, or the deviation from this score in whatever way, as sum of squared error or root mean squared error or whatever, would give you a measure of the purity of this. ओके इसका मीन निकाल लें फिर हम ओके 250 plus 260 plus 280 plus 200 plus 300 divided by 5. So 258 is the mean. So now maybe you can use the sum of squared error as a criterion. ठीक है, sum of squared error क्या होगा फिर? Simply पहला वैल्यू लेंगे हम, पहली वैल्यू क्या थी? 250 minus 258 whole square plus दूसरी 260 minus 258 whole square plus तीसरी है 280 minus 258 whole square plus 200 minus 258 whole square plus क्या था 300 minus 258 whole square. So this is now a quantification of the impurity. The larger the value, the larger will be the impurity of this set. ठीक है? Of course, you can think of a scenario के जो आपके पास सेट आया उसमें सारी वैल्यूज क्लोज बाय है 250, 251, 250, 252, 255, 250. 255, 252. So in this case, the sum of squared error will be smaller. So which set is purer? This set is purer as compared to the other one. How do you quantify? Using SSE, sum of squared error. ठीक है? So error with respect to the mean. Mean is kind of representative of this set of values. Of course, if you want to be, for example, it's kind of the central tendency. You can use the median as well, but of course that is less commonly used in practice. Mean ही use करते हैं हम. ठीक है? So इस तरह आप impurity निकाल सकते हैं, and then of course the rest of the process remains the same. How? So basically, let's say you have chosen gender. Gender के दो splits होंगे, male सारे इधर आ जाएंगे, female उधर आ जाएंगे. Male की अब impurity निकालेंगे, female की impurity निकालेंगे. In terms of SSE, इसका average SSE आ जाएगा. After split, before split एक SSE आएगा. Before minus after would give you a criterion for X, this attribute. You check for all. The one that gives you the highest gain would be selected. ठीक है? So in this way, you can build a tree, decision tree for regression as well. Sometimes they are also called regression trees, not just decision trees, but regression trees. So is this clear? So if you want to read up on this, this is also available in your textbook, main textbook, which is chapter 8 point, I think 2 or 1, I'm not 100% sure, but it's chapter 8, of course. But you will also find it in other textbooks as well. The other textbooks, Introduction to Data Mining, usme bhi hai, and you can find it on the web as well. Okay. So for regression problems, we use SSE as the criterion, splitting criterion, or its variant. You can also use root, mean, squared error if you like, and that is sometimes preferred. I would prefer it because it does normalization. So mean bhi lenge, because, which is divided by number of examples, and also taking the root because you get a value that is of the same unit as the unit of the data set or the scores. Okay. Okay, any questions? All right. So now, so far we have talked about attributes that were nominal, meaning that they had labels. So what happens if you have attributes that are continuous? So let's say you have attribute like age, and now age is a continuous value. Let's say between, let's say 10 and let's say 70. Not from a possible set of labels, but now it's from a range from 10 to 70. Okay? So how do you handle such scenarios? So you can handle that as well fairly easily in classification problem. So let's say, let me write age and the label as pairs. So let's say मेरे पास age 15 है 0, age 20 है 1, age let's say 20, 22 है let's say 0, 25 है 1, and let's say 30 है 1. ठीक है? So the first thing that you have to do is you have to sort your data set according to the attribute values, and I've already written it in sorted form. So 15 है, 20 है, 22, 25 and 30. I've written in sorted form, of course with the appropriate labels. So 15 की class label 0 है और 20 की 1 है. So there is a change in class label as you move from 15 to 20. So you, by the way, if you have a continuous value like this age, we have the splitting criteria simply age is greater than equal to some threshold t. If this is yes, you go on one side. If it is no, you go on the other side. Meaning that you have binary splits. So we want to find this t, which is the best t, okay, for the binary split. So there's a change in value between 15 and 20. So one possible value for the threshold is a value, some value between 15 and 20, let's say 17.5. And then there is also a change in value between 20 and 22. So another possible threshold for the value for the threshold is 21, between 20 and 22. So then there's another change between 20 and 22 and 25, and then you can maybe choose a value between these two. So then they are now actually, then of course after that there are no changes. So the possible options are, for example, 17.5, 21, and maybe 23. So you will split the data using each of these options and compute the information gain. So you first split the data using 17.5, meaning that 15 would go to one side, 20 and higher go to the other side. Compute the entropy and information gain. The other option is split with 21, 15 and 20 goes to one side, 22 and higher goes to the other side. The third option is 23, 20, 15 to 22 goes to one side, and then of course from all of these possibilities, select the one that gives you the highest information gain. ठीक है? Is this point clear? So there were three possibilities for this attribute. So, and let's say if you are only considering this attribute, we will find which one would give us the highest information gain. But let's say there were other attributes as well. Let's say gender bhi tha, or let's say education bhi tha, or age tha. So in this case, you will compute information gain for gender. You will compute information gain for education. And then you will compute information gain IG for age with a particular threshold, let's say T1. You will compute information gain for age with another threshold T2. Information gain for age with another threshold T3. अब इन सारों में से जो सबसे ज्यादा आती है वो आप सेलेक्ट करेंगे. So your possibilities have now increased. ठीक है? So age की अब 3 possibilities हैं, while gender, which are nominal, and एजुकेशन विच ऑल्सो नॉर्मल, उसकी एक ही पॉसिबिलिटी है, ठीक है। और इन सारी पॉसिबिलिटी में से आपने वो वाली सेलेक्ट करनी दैट गिव्स यू द हाईएस्ट इंफॉर्मेशन गेन. So this is actually another very powerful advantage of decision tree. They can handle mixed valued attributes very nicely. So kuch nominal hai, kuch real valued hai, there is no problem. You can solve it or handle it in the same framework. ठीक है. So if this was a continuous regression problem, तो regression problem में obviously जो थ्रेशोल्ड है वो इतने आसानी से नहीं निकलता. तो वो फॉर एग्जांपल रिग्रेशन प्रॉब्लम में क्या होगा, आपके पास एज है 10 है, 15 है, 20 है, 22 है. 10 के साथ कोई कंटिन्यूस नंबर, लेट्स से सैट स्कोर की बात हो रही है, 250 है. सो तो जहाँ आप लेट्स से 260 है, लेट्स से 280 है, and let's say 200 and so on. So now you will have to have, of course, sort तो आप करेंगे according to the value of the age, but now you will take the mean. अब options क्या है, आप either 10 और 15 के दरमान करेंगे, 15 to 20 करेंगे, 20 to 21, सारी आपको ट्राई करनी पड़ेंगी और उसमें से देखना है कौन सी would give you the highest increase or decrease in SSE. ठीक है, highest gain after the split. So of course the criteria for regression is SSE, not entropy or information gain. So any questions? So next class, I think I'll talk about a bit about pruning, which is an important concept in decision trees. We'll also talk about random forest and extra trees. Hopefully quickly, I want to finish it probably next class. And then we'll also very briefly talk about the k nearest neighbor. So, which is another classification technique. ठीक है? Any questions? Any questions? So for this part, as I said, you can read chapter 8 of handbook, and also you'll find it in many other books. So we are basically covering the basics of decision tree learning. We'll also briefly discuss the basics of pruning, which is the next class, and then talk about random forests and its application, which is also very simple. We won't go into too much detail. Of course, very easy. And then, of course, we'll briefly talk about k nearest neighbor. So that's all for classification. Then we'll move on to clustering. So any questions?